Hello and welcome. I'm Bill Wake. Today we're working on the Elm interpreter written in Swift, I guess today in the last previous 11 episodes. Up till now, we've been taking this parser combinator approach, and yesterday we pitched it. So we spent a little time looking if there was a little more stretching we could do, but in the end, I decided there's just too many downsides to it right now. So we're moving on to the sort of what I would call the old-fashioned approach. Split the lexical analyzer and the parser, and I'm going to use recursive descent unless it turns out it's just completely not suitable. But I haven't found a good Elm grammar, so we're inventing that too. And let's take a look. So the bottom part, expression goes to float or integer, and float is a bunch of digits, integer is a bunch of digits, but float also has either dot digits and or plus or minus digits. We got that going last time, kind of throwing out the old way, catching up the new way, and just implementing that. The other stuff we've done so far, we've done newlines space. Actually, I don't know if we did newlines, but we've got newline spaces, end of line comments, which is dash dash and the rest of the text, and nestable comments. We kind of, the nestable comments was kind of the last straw. Trying to get that working with the parser combinator and then dealing with that, it just kind of fell apart. The funny thing with nestable comments is they can't be handled with a straight token analysis kind of approach. We may fudge it a little bit anyway, but if we'll see what we can do. Let's see. I guess that grammar's not quite right. Right. It's sort of like anything or nestable comment. Star, maybe something like that. It's probably more accurate. Okay. We're not ready to deal with that one. We're still back here. Okay, so let's go to the code. And I did not run tests, so let me just kick those off and we'll talk a bit while it's going. So all we've got so far is this lexer. He has a get method that produces a token. We detect into file, that's new. We detect 0 through 9, that's the case of numbers we talked about. And otherwise we say it's an error. We don't handle spaces, although we once did. So let's see up here, this approach, the parser combinator, a literal space, many of those all combined. Okay, and then we have newline is just a literal newline. Combined converts it from the token domain to the Elm interpreter domain, but we're not doing that anymore. So let's just tackle spaces, and we have a spaces comments test. So we've got something to start with. Okay, so in this case, I guess what we want to do is we want to see that one or more spaces. So this input should return, I think we'll say an Elm ignored, and have this ready to go from the rest. We haven't been checking the rest. I've got a different approach now. Let's see down here. Oh no, it's on the integer one. Where did we put those? Lexer tests? Okay. So we got a check token that basically you give it an input string and what token do you expect, and we check that that's the right one. So let's just do a check spaces. Returns Elm ignored. Do we have a token like that? Error end of file. We don't have a space one. Let's add that in. Back to lexer tests. I'll keep that there for a moment. Okay, so let's say spaces. Okay, we'll let that let that go for a second. So if we have space x, we expect to see token dot spaces. And there may be a better name, but we'll get there. So Lexer has the spaces. We want to value spaces. Kind of going from least significant to more significant here. Error end of file spaces. So we would like to see that, and this test should just fail. Okay. Switch must be exhaustive. Yeah. One of those. No member spaces. That's funny. I guess this blew up before that. Okay, so our parse, I'm going the bottom order to the top. I think I'm going to switch that. Forgive the refactoring in the middle of a failed test, but I'm pretty sure I can execute this one correctly. All right, and we don't have a case token dot spaces, and we're going to return token dot error. Oh, this is parse, has to return ASTs, so we'll return elm.ignored. Maybe we should be going at our Lexer directly. Is that what our tests do? They call parse, I think, don't they? We just looked at it. No, it calls Lexer. Okay, so we're going to make that an error for now. Well, I guess ignored. Maybe I'll just throw something wrong in. 42. Types dot it. No. Okay. I don't know. I'm not terribly fond here. The problem is I don't know what we do with spaces yet. So in some languages, spaces, I would say in many languages, spaces just basically get ignored. They separate things, but nobody keeps track of them. Oops. Oh, I updated my do I have an iPad? I updated my compiler and it apparently resets that when you do it. How horrible. I didn't set it to the other simulator because I wanted to go back to my phone. At any rate, many languages, they ignore spaces. Some languages, spaces are actually significant and they're required in certain positions. I know Elm has some requirements around spacing that are a little funny, so I don't know if that matters to that or not. The other place I know spaces kind of count is some constructs require that you align columns, so they don't care how many spaces you put, but you got to put the same number for each one that's in that structure. And I don't know if we need the spaces to do that. We certainly need tokens that know their column number if we're not going to have the spaces there. Same thing with the end of line. I don't quite know the rules, but we did some experiments, and if you do 42 on one line, 37 on the next line, that's two valid expressions. If you put them on the same line, it's like, no, I don't know what's going on. So there's something going on there, and that may be a REPL issue, read eval print loop, and it may be something else. Okay, so we don't know. All right. The slow startup. Usually I get that going first. I'm not sure what happened today. All right. At any rate, let's take a peek back here and start thinking about our next thing. Okay, we don't handle the space yet, so that's going to be an issue. We'll put a space. We'll look for a space, and then and then I think we'll just call a number of function spaces. And so we should get token.error back and fail the test. And then we'll add the case for the space and loop over it just like we did. Where's keep? Yeah, or digits. Yeah. So digits is very much in the spirit of what we're going to do. It's interesting. We got a little, we'll have some duplication. I don't know, maybe not, because we don't need to keep the spaces. Okay. Let's see. Are we getting anywhere here? Do I have? Yes, a simulator. Okay. Oh boy. Put that over here. And the irony, as usual, it'll tell us, oh, it took 0.03 seconds. Wasn't 3 minutes. What are you talking about? All right, but at any rate, we'll want something that handles many of these things, and we could keep him and then throw him away. I don't know. It may be that number. Often enough, we need to keep the contents of this thing. So maybe this needs to grow a little bit, and just maybe that should be something that's kept at the top. And then we reset it when we start a new token or something like that. Because when we get to words, right, when we get, variable names, things like that, they have multiple characters, we're going to want to accumulate. And then once we have that, this loop, we can generalize this. This is a range. We could, I think, define a set of digits, maybe profitably. I don't know if you can pass a range to a set. My goodness, guys, come on. Well, I guess I will. While we're waiting, I'm recording the videos, starting with this series, and putting them on YouTube. So there is, if you find my YouTube channel, if you search for Bill Wake Elm, you will find my YouTube channel, and you can subscribe to that if you prefer to do that. They're going to be lightly edited. I basically cut out the breaks. And if there's something that's just completely, totally, mindlessly boring, I've done a little fast forwarding. And if there was an issue with the recording, I recorded a 20 minute or so summary walkthrough of the code we did that day. So I know I've messed up a couple, or something has messed up a couple. So that's available for you. The other one is I put a blog out yesterday. I've been writing a series of things on TDD, and kind of getting deeper into how do you actually choose the test cases, because I think that part of the advice is a bit underdone at this point. And so I'm trying to kind of fulfill that. And this time I talked about booleans, characters, and enums, and then the notion of product and sum types. Okay, so product type is things like a record or a class with its fields, where the number of possible values is sort of multiplied by the how many choices do you have for each one. So if you have 2 booleans, you got 4 cases. And if you have 2 booleans and a 16-bit int, you've got 2 to the 18th cases. So that's those. And then sum types are more like unions, or for us in Swift, these enums where they can take values, they're definitely more like a union type that sort of adds the number of possibilities rather than multiplying, because you have to choose one. You can only be one of these things at a time. All right, so our test succeeded by failing. That's actually a good thing. I've lost my debug area down there. Where did that go? There we go. Okay. No, it actually took 0.944 seconds. Don't be fooled. Okay. So test return spaces. space is not equal to error. Yeah, that's true. Okay, so in here, we're going to say if you actually see a space, okay, what are we going to do? Well, we're going to do the same kind of thing as we did down here. So I'll even, you know, yeah, let's see. Well, let's just write a loop. Okay, while the character equals a space, which we know we have one, so we're okay to do this. While it's true, we're going to skip forward and then set the new input, the new first character. So we always go in, we have the first character ready to go, and when we leave, we always leave the character ready to go. Okay, and then in the end, we're going to return token.spaces. Okay, so read characters, drop the first, grab the next, and keep doing this while we got spaces. Okay, this will be a little closer to 0.944 seconds. I've got to look up. I think there's easier ways to do this, but at any rate, 030.302. Okay, that's reasonable. Much nicer to do this in a second or two. All right, so hey, spaces are done. So let's get our to do and mark it done. So this is the 28th, 21-01-28. This is in fact 2021. And then I guess I'll fill in last time. Refactor, and we switched from parser combinator approach to a lexer plus parser approach, and implemented numbers. Okay, and now we're basically, I mean, this is not, page 47 of Martin's book kind of refactoring. This is a major shift in the algorithm approach that we're doing. So it's a stretch, but I'll say re-implement spaces, and this is parser combinator to lexer plus parser. Okay. Nice. And let's see the spaces comments. I don't need this test anymore because I'm not matching that anymore. Okay. New line. I think we have to deal with new lines separately. So let's add a test for that. And we may well find out that we don't care about them. I'm okay with that. We'll deal with it if it comes up. All right. Token. That's over here. Down a ways. Token spaces new line. And this should fail. We'll get an error. Oh. What? Oh, did I delete too much? Yes, I did. Okay. And we must be exhaustive. Let's just handle that. Default. I'm just going to say print parse head unexpected token. And right now we're not saying how you handle spaces. So this is okay, and we'll return Elm ignored. Okay. Just to kind of lock this thing in so it's not in our way. Switch exhaustive. We dealt with that. Extraneous token has no member. All right. new line is not equal to error. Okay, and our lexer. Here's space. We need a new line. Case new line. This is just one character. Let's see. So, well, we're going to refactor in a moment, but return token.newline. Okay, should pass. Okay, so I'm gonna provide a method skip. Like this would be nice. Let's extract this. I mean, normally this is called like next token. Okay. And we can call it here. I mean, I don't know. Is that the best thing to do? I doubt it. The spacing of this, here's keep. Let's put it down here. It's kind of the bottom. Okay, now this can call next token. Okay, and I'm going to extract this to a method, and we'll call it spaces. Then I'm going to move it down. I don't know, maybe just here's far enough. Okay, and I guess I can, just to kind of keep everything at the same level, you know, that notion of a composed method. So all the steps are being done at the same level of things. So this is kind of like that. And we'll put this here. Okay. Can't find new line. Okay. I mean, that's moving forward. We've still got this duplication of the while. All right. Yeah, let's make sure this works. I didn't push anything yet today. That's terrible. All right. I had set up a TCR kind of thing that would automatically push whenever things went green, but it was just kind of too much of a pain in this environment. So sorry. Okay. Tokens for spaces and new lines. Refactor to extract methods. Okay. Sorry about the phone call. Let's see. So we've done. Do I have keynote here? All right. So we've done new line. We've done spaces. Both those are acceptable. End of line comment dash dash. Okay, that should be doable. Okay, so our tests, and I probably should have. We'll deal with this duplication across tests in a bit too, but let's start with the end of line comment. All right, so here's our spaces comments test. Eventually we're going to get rid of all these. New line matches one new line. End of line comment just matches 2 dashes followed by a new line. Okay. This is AOL comment. And I think we're going to make him return spaces. It's a little tricky. Again, I just don't know the space structure of the language. Lots of languages, a comment is treated as a space, and so we'll do that for now. And this should fail. Okay, and our lexer, and we're going to have to nudge this a little harder, I think. Okay, so if we have a minus, okay, well, basically we want to consume that. Well, let's make things easier for ourselves. Let's yeah, minus or EOL comment. Let's call this function. Okay, so we come in here with a minus. So we want to eat the minus sign. So that's just next token. This should be next character. And I don't know. Like, what do you think? Is that too cryptic? CH for character? I don't know. All right, but we will skip the next character. Okay. If the character is a minus, now, okay, then we know we're in this mode. Okay. And if it's not a minus, as of now, we're saying it's an error. Okay. If it's a minus, we got dash dash, okay, and then we want to say, well, CH is not a new line. We're gonna skip characters. Okay, now when CH is a new line, we've got the end, and we're going to leave that new line ready for the next thing, and a new line token will come back. But in our case, whoops, we return a token dot spaces, we said. Okay, I expect this to pass. Oh, I've jumped ahead of my test case, haven't I? All right, we don't have any test that justifies this yet, so let's deal with that one. Inline comment. Let's see, inline comment 2 dashes return spaces. That's that case. Match just 2 dashes. Okay. Inline comment matches text after dashes to end a line. Okay, so this stuff. Inline comment, 2 dashes and comments, return spaces. Our input, And we expect token dot spaces. Right, should fail. All right, passed. Okay. Yeah, we're in. I'll tell you what's going on. It matches dash dash and says good enough, and then it leaves blank stuff new line X there. Our test is not strong enough to detect the stuff we expect at the end. Let's see. Let's put a trailing. What can we do? Expected lecture.get. All we can do is a get. Let's put a oh boy. Can I put the trailing token? Do I care? See, the real thing is if I call lecture.get, I expect to get the two tokens. And let's make a new check. Let's check tokens. And let's pass in an array of tokens. Lecture.get. Yeah, that's not really going to work that way. Okay, what we want to do is we want to say what are we going to do? I guess we want to say for each thing unexpected, maybe it's a for each. Let's say expected token in. Okay. So what I really want to happen is I want you to run through each one of these tokens, and really expected is a token to me. Oh, this is not right. Okay. Probably should be token here. All right. So I'm going to run through the list of tokens you give me. I'm going to call lecture.get and compare it to the token, and I should match them all. Okay. Let's call check tokens. And it's only going to get as many as I give it. So I'm going to get token.spaces and token.eol. New line. Okay. EOL might be good too. And this I expect to fail because I think it'll come back with a blank. Get a token.error because it had blank stuff. Yeah. New line is not equal to error. Adequate message, not amazing. Okay, at any rate, that justifies this. Okay, that handles end of line comments. I'm going to push a little something on this thing. So I guess I'm a little behind here. So really we were refactoring from combinators to Lexer plus parser. And the story we worked on was just dash comments. Okay, This is re-implement new line, re-implement end of line comments. Okay, so we just did those. The thing I don't know. Well, we can get rid of these parser combinator-y things. That's fine. Input. We already made a my input. Well, my input. How about with character array rather than string? Okay, but the other thing I'm worried about is handling end of line with end of file. So the issue is, I don't know if you, when you get to the end of a file, are you okay? And I think I'll write the test and then delete it because I don't want to handle it right now. Lazy. Okay, but let's call it func test EOL comment. I guess I can't blame it for not completing that. Comment at end of file. So if I check token and all I give it is dash dash, no new line, I kind of want to see token.spaces. All right, now are you frozen? Yes, he is. Okay, again. All right, so I know we're not handling this. The reason is, let's see, I think it's in here, my input. Yeah, so the way we handle input is if you don't have a first character, if you don't have any characters left, we just return myinput.eof. And so since we're searching for new line, it keeps reading, it keeps calling this and it keeps getting myOF, and it's like, good enough. So maybe I just have to handle this. It's not equal new line. Well, and it's not equal to my input.eof. Okay, if the character is equal to my input.eof, we should stop and return spaces. All right. See, I resist something that takes 20 characters in 2 minutes. I'm sure I'm the only one like that. All right. Yeah, so that's good. So the lesson there is anytime we're searching for a not equal something, we probably need to do something like this. We probably need to check for end of file, and how do we want to handle that? In the case of spaces, the comment like that, it's not an error. It's acceptable. If well, I don't know what else would care. Not very many things do, so it's not going to be a common problem. All right, let's commit this. So we handle EOF end of line comments. Comments dash dash. Okay, that I believe takes us to where we were. We had this one done. We started this one and got all balled up. It does have an anything, so we do have to worry about that issue we just faced. But these things don't. They always repeat some specific character or group of characters. Okay, so we're going to look for this one next. But it's a good time for a break. It's been a long Pomodoro. So let's take a break, 2 or 3 minutes. We'll come back and move forward past something we haven't done yet, these nestable comments. See you in a bit. Welcome back. All right, let's tackle this nestable comment stuff. We've got a few cases. Let's see, dashes after end of line. That's done. Let's get the to-do in shape. Combinators to Lexer parser. I think we're at this story. It's nestable comments. Okay, and we did end of line comments. Yes. Okay. Okay. Spaces and comments. So, there's several tricky things. I think this is our list of things we weren't doing yet. This one is our empty comment. Okay, and it's all a little tricky. One of these exercises I have given people, I taught compilers years ago, and one of the exercises was write the regular expression to parse like backslash star whatever star backslash, so Java style comments or lots of other languages, C#, C++. It's tricky to write that regular expression, and I know I did it at some point, but it's been a while, so it's like now you got two problems. Let's just start in the way we do, and we'll take this case. All right. Brace dash brace. Okay. So test empty nestable comment. Empty nestable comment returns spaces. I don't know. I'm kind of starting to become a longer explainer here, and I'm probably gonna trim all this stuff down at some point, but just to get consistency within a file, it's usually my goal. Yeah, all this duplication. And I don't know, I don't think it, I mean, returns int, and the word int is right there. I don't think that part of the comment's necessarily adding a lot. The interesting thing is more to read the left-hand side of these things. Okay. But empty returns spaces. So if you have check token you get token dot spaces. Excuse me one sec. Okay. And should fail. We're not looking for that brace at all yet. And I don't remember. It may get complicated as we go, but let's deal with this next case. So we have get 0 through 9s. Let's do the braces. I guess we'll put it above. Nah, that's going to get old. Return nestable comment. Okay, and this is actually, let's see. I guess below this one. Right. Okay. So we come in this thing with a brace. So we need to consume it. Okay. Already I'm getting annoyed with my well, we'll call next ch. Okay, so we just ate the brace. Now we expect to see, well, if we don't see a dash, then we we are going to return an error at this point. Token.error. Okay. And maybe we should be checking that first, but let's get on. All right. Now, if the character is, then we do next character because we always consume what we look at. Okay. So one of my days to get about 10 phone calls about my insurance because if I owned a car, it would own insurance. Okay, so now we expect to see a minus. Okay, there's a pattern here, huh? Error. If it's not minus, then we're going to consume it. And then we expect to see a brace. And consume it. All right, and then we return token dots. Token dot spaces. And all is good. Okay. I'm curious. All right, I believe this will pass. I guess. But I'm very curious about how this nestable thing works. If you open a comment and don't do it, what happens? So let's do Elm REPL. And we're going to say, here's a comment. That should be fine. Oh, interesting. Okay, 42 comment. No comments first. Wow. Add some spaces here. TSOL equals something. You know, they have such good messages, and then you get stuff like that. It's like, what? TSOL. Okay. I'm looking for white space. This one's legal, but if we do this, I don't know what's going to happen. Yeah, we're looking for end of a comment. Now, I think we can, in the REPL, I think we can do this. Yeah, we can carry over a line. Right, but if I do 42 dash comment dash, does it detect an error? Yes. And if I put this one in, it still needs an error. So we are required to close any nestable comment values we open. That's worth knowing. Okay, now let's try another one. Here's minus dash comment brace dash minus. That should be okay. Oh, I put too many spaces in. I gotta have a space here, otherwise I'm starting a new one. Yeah, that's okay. And similarly, even if I delete this space, yeah. Okay. Whew. Okay, I guess this is okay. It passed because we had too simple of a situation here. So this is empty comment. Now let's put some stuff in that's non-empty. So let's do this one again. Token.spaces. All right, should fail because we require just the 4 characters, not anything else. Okay, now this is where It's getting a little funny. So, all right. So I have this. I have that. I definitely can. I definitely can do something like while character is not a space, next character, or not a dash. Okay. And take out this line. Okay. While the character is not a dash, so there's no issue here. We just keep going and do next character. This is eating the dash character. All right, and I think this will pass. Okay. Let's see, spaces, commas, test. So this one went away. And then nestable comments ending with dashes and no spaces. Okay, I guess I'll borrow this. So function test, nestable comments ending with many dashes, no spaces, return spaces. Okay, and we'll check token. And we'll steal that too. Okay, should fail. Right, because we get the minus dash, the dash here. Sorry, we do brace dash, and then we see a dash, and it's not followed immediately by a brace. So when we saw the dash, second dash, we stopped our loop, and we said, okay, I'm getting out. You better have dash brace. Well, he's got dash, 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 brace. And okay, so he's out of the loop here. Now we know we have a dash because we looped over it not. Okay, so while the character equals dash, do this. Okay. Yeah. I mean, it's funny. We're tackling the two worst the worst things to Lex. You know, it's comments and numbers, and we're doing those two first. But I think this will pass. Did I run the? Yeah, it failed. Okay. Now we're going to have to do some cleanup and stuff. But let's document what is legit for this. So you got to have this, and you got to have this, and we're going to try a regular expression. So what we have now is not dash star because it's a while, and followed by dash plus. We got to have at least one followed by a brace. Okay, and you know we get these situations, and well, the situation is we kind of have to do look aheads, and I'm kind of putting it off. um, See, it gets tricky because if we could look ahead and see that we had not dash followed by brace, then we would just keep going in here. Okay. Um, and this is still okay. We will clean up these loops and stuff at some point, but there's always going to be some level of ifs and checks and things. Okay. What's our next test? Right, we did this one. Well, actually, I think this test will work too, right? I guess I could just pull the braces. We expect this to pass. Okay. Nestable comment ending with many dashes. Yes. Internal dashes. Okay, this is kind of where we left off. Well, now regular expressions let you write things that need the future. So I could do this dash that and change this to a star. That's a legit refactoring of a regular expression. That is okay. So in a way, I would like to be able to say this. And really, this is the same as taking those stars off. And that. Okay. And maybe this not star. I mean, actually, it's if you say not dashes or dashes star, you're really just saying anything star, which is a dot in regular expression language, or at least grep or one of these. Okay. That's true. And that's where we are right now. Well, no, that's not where we are now. That's kind of where we'd want to go next, I guess. If we did this test. Nothing, 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 and then these two. See, it's this one. Well, now there's probably a way to make this repeat work. I think I can say, what do you say? Is it do? Swift is do while. Do. While. Nope. I end up looking up the most basic thing. Somewhere I have a cheat sheet for Swift. I don't know. Can I find it? Apparently not. Swift repeat until. Is it repeat while? Repeat while, okay. If I said I want to repeat this stuff, no, I'm not going right here. Okay. Let's get the test case in place first. Local variable next to you. Yeah, okay. Make sure I didn't mess things up. Okay, so what I want to test is test nestable comment can mix dash and non-dash returns space. Okay, so that's all good, but I would like to be able to say that dash dash that something. I want to mislead it. Okay, and this should fail. Okay. All right, so we're kind of doing something like that. We got to get our look aheads right, I guess. So if we're going to repeat something. So we're going to repeat our non-dash characters. Okay, so arbitrary characters, we go along, we're fine. At some point down here, we have to say a while. Character's not equal to brace, I guess. I'm going to try. And we need to close. I guess we'll pull these together like that and that. All right, so we grab our non-dash characters, and then we grab these well, after a non-dash, we got to have at least one dash. Okay, if character is not a dash, we know it is, right? Okay, so we know we got a dash, and we're going to skip dashes, and then if the next character is not a brace, then we're going to go back through the loop again. So we saw a bunch of dashes, but if we saw one dash and we saw a brace, we go around again. I think this will pass. We're getting into the ugly for sure. Okay. Now, at this point, this should not be needed because we know if we exited this loop, we found a dash followed by a brace. So that should be okay. We're just eating the right brace. All right, so I'm claiming that still passes. Okay, so have we done what we said? So we got a brace, we got a dash, we repeat. I think I can make this, maybe this repeat should be more, whatever that repeat is, we got to have not dash star, that's the first while loop. And then we have dash plus, and then a brace. I think that whole thing starred. All right, so can we think of a counter example? So if we come in with brace dash 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 x dash brace. Okay, so we skip down dash dash, goes twice, character's not dash, it's x. We skip over the x, we see a dash, it is a brace. Okay, I guess in my head I'm content. I think our case covers it pretty well. Yeah, this covers that case I just kind of described. It doesn't get misled. Okay. that is that. Okay, so this class can go away. It's spaces and comments test. Spaces, comments test, delete. Move to trash. Okay. Okay, so nestable comments, but without nesting. Okay. Now I need the break. All right. This is okay. All right. Now the issue is if you run along and you see a nested comment. Now, a lexical analyzer using regular expressions, you can't parse something that requires matching of parentheses or matching abstractly parentheses. So we can't require it to match. We can't write a regular expression that matches the left paren or left brace dash to dash right brace for arbitrary nesting. This is where you slip into recursive descent. Now, recursive descent says make sure your grammar doesn't have any left recursion, because otherwise you call A, you first call A, that kind of thing. But if you make each grammar rule a method and you have the same kind of convention like we do, that the first token is always primed and ready to go, and when you finish, you leave the next token ready to go, you can call recursively to get those handled. And so I think at some point, well, the thing I have going is if I see a brace dash, I should go into nestable comment right at the brace. Okay, that would be a good thing. Now, unfortunately, I can't. I can't. Detecting it's a little weird. All right, but somewhere at some point, I'm going to have code that looks like this: equals nestable comment. Underscore equals says throw away the result, because I know I'm getting a token dot spaces. Okay, and nobody cares what the contents are. So let's try some tests. Okay, so test nestable comment with empty nested returns spaces. Okay, that should return token.spaces. Okay, and this should fail. Okay, so we get in there. And this, I think we're gonna hit the wall on something here. Okay, so now this thing, it's not this. I mean, it's also not a brace. Let's duplicate this line. This is right so far. It's not a dash, it's not a brace. But if you should see a brace, it's optional. If you see a brace, followed by a dash, now this is the tricky bit. So if you see a brace, I would like you to attempt a nestable comment, but only if you have a dash after it. Okay, so basically what has to happen is we have to have a peak. Okay, and I don't know. I think sometimes you write it like this that says peak. We'll take it to be that, and then it's a nestable comment. Okay, parend, and it's all in a star, so it's okay. And this is basically this. And this whole thing is, or you just have a brace that was sitting out there and that's the way it is. I mean, come on. This is crazy. Okay. So this is one way. I mean, this is the sort of recursive descent way that you could do this. The other way I'm thinking is like, can we define? I just wonder if we could define some the pieces. So one piece is brace dash, and then another piece is neither braces nor dashes. I mean, if a brace dash, bunch of non-dashes and braces, if you could chop that off the front, could you keep track of it? Like you'd have to count it or stack it or something. But you could count and say we saw one brace dash. But I think one way or the other, you're well. Okay, let me lay out what that's going to be. So in that case, we saw brace dash. We're going to define four things. I think four. Not brace dash, brace or dash, star. Okay, so the brackets are just saying pick one character. The caret says not these. So if you say, I find a brace dash and bunch of stuff that's neither braces nor dashes. Okay, that seems like the prefix of any comment, right? And then the suffix is something like dash plus brace. Okay, so this is the front of a comment. This is the end. Well, I guess end goes with start. Start of a comment, end of a comment. So you see a start of a comment and then something and then the end of a comment. Now what can you see that's the middle of a comment? I think one thing is one or more braces followed by not a dash. Okay. So that's a bunch of braces. Those are legal. Another middle. Another thing in the middle, I guess I'm going to have at least 5, is we could see a bunch of dashes plus, yeah, we see at least one dash and it's not followed by a brace. Okay. We could have that in the middle of a comment. And I guess we can have a start of a comment can be in the middle as well. So the question is, do I want to try and do recursive, or do I want to try and keep a counter, like a depth counter? I mean, that might be enough. It's breaking the regular expression stuff, but only by a little bit. Wow. But I think either way, do I need look ahead? So with this one, if I see number 3 in the middle of a comment, I'm good. But I don't know, at some point I'm going to see the number 1. I mean, I see all these braces. At the last one, I got to look and decide, is it a dash following it or something else? Well, I don't know a good way to decide this. If I knew if I needed more peaks, it'd be easy because I'd say, well, I need it for this, I need it for other stuff. Because I would really love to stop at a brace and peek and see if his next character is a dash. And if it is, then my character's a brace and I know there's a dash, I can call nestable comment. Otherwise, I just skip that character. Okay. Let's add that to that peak. Oh, this is not easy. I don't want to be doing this all day. So the other thing on my mind was, at some point I wanted to make this thing be an array of characters. And then my peak would be very simple. It's like, your index, and you just add 1 to the index and look ahead. And unless it's end of file, and then you just make it an end of file character. All right, let's do some trimming. So are we green? I think we're not, right? That last test was too tough. No failures. Oh, now here's our we're going to do our check tokens again. So we want to see a token dot spaces. And token dot int. A 9. Okay. Where's our other place we use this thing? Token new line. Well, that would be okay. No, let's keep the int. Okay. Now this should fail. Okay. I'm going to mark it out. Take a different approach. Okay, I don't know what we have. Let's lock this in. Nestable comments so far, and they're moderately useful. They're up to Pascal level, but not nested. Okay. Where are we going next? So we're either going to put the peak, we're going to switch this thing over. Actually, what we're going to do first is clean stuff out. We got a lot of mechanism we don't need anymore, so I want to get rid of that. And then we'll come back and So we'll come back, get rid of that. Then I think we'll modify the my input stuff, and then we'll add the peak, and then we'll tackle the nestable comments again. That's starting to sound like we might not finish nestable comments today, but we'll see. All right, so let's take 2 minutes and see in a bit. Hello, welcome back. All right, so first thing, we're getting rid of stuff we don't use anymore. So we handle lit spaces, we handle nested new lines, end line comments, and that's good. All right, here we are on the inner comments. Okay, I mean, we're not doing it this way. Let's get rid of it. We're not doing that. Okay, characters down integer might still mean something. Let's see, who's calling it? Nobody calling it. And this is an explanation of what it means to our overall approach. Let's put this in our to-do if we need to reference it. Okay. And now we have struct Elm parser with an enum. We don't need that. Okay, we got our tokens, which is going to grow. We got this massive and growing thing. Okay. But that all looks reasonable. Let's see if everything builds. There may be some tests still calling in some of those things. Nope, good. Okay, we got our Lexer tests. That's fine. Interpreter tests. Parser, what's in here now? My input we're using. My Elm parser we just added. This stuff, I don't think anybody's calling. This is all that combinator stuff that we kind of gave up on. Okay, we'll just comment that and build. Should be some tests. Yeah. Okay, parser test helper. Let's try parser tests. Okay, all the monad bind stuff. Yeah, these are testing the parser combinators that we defined. All right, let's dump those. Parser tests, delete. Parser test helper, delete. All right, run. Okay, this can now delete this. All right, that's much smaller. Okay, and Lexer is good. Interpreter is still pretty minimal. Character categories, yeah, we're using as digit. I think we could be. Plan category tests, yeah, that's fine. Interpreter Lexer tests. We're not using UI tests. Okay, so I wish it told me how much code, but we just deleted several hundred lines. Okay, remove dead code from parser combinator approach. And if it's dead, it's a refactoring. Mostly dead. I mean, some of it was tests, and I don't know if you want to call that dead or not, but all right. Interpreter test parser. Okay, so what did I say we're going to do? We got rid of the dead code. I think we're going to switch this. Oh, do we have an Elm parser anymore? Let's rename Elm parser to parser now. It's all Elm. Okay. Now, my input. We know we call drop first. I don't think anybody calls contents anymore, which I didn't like the name anyway. Find selected text. Let's see if anybody's... Yeah, that's dead. I don't think anybody calls this. Oh yeah, I can go colors in here. Starts. Something's not updated, but I think we're okay. Okay, so I would like to think that I could switch this to characters. So let's try that. And the way you do that is array of input. Okay. All right, so we get an input string, but we're converting it to an array of characters. The way you get the first character, well, current is 0. That's true. Okay, so if let's put this down where we can type. Okay, if current is greater than or equal to input.length count, well, we're going to return myInput.aof. Okay. Otherwise, we're going to let result equal input subcurrent because we know it's in range. And we're going to increment current. And we're going to return result. Okay. Actually, we don't even increment current, do we? We can just return that thing. So that only asks for the current value, the first value. I don't know if that's a good way to do it or not. All right, and then this thing increments current. Input. Oh, we're doing that. Oh. Well, first, I don't think I want to make this be a value type at this point. I could on the current position, but we're not doing that functional approach. I don't think it's going to I don't think it's going to make anything better. Character of type, expression of type character is unused. Oh, I guess we'll say return. Okay. You start empty, or you start at the front. If you get nothing in, you're still at the front. Okay, so if you're greater than or equal to count, you return input AOF. Otherwise, input subcurrent and drop first current plus 1. I'm going to change this interface, but let's see if it works first. I think it will. Yes. Okay. Let's see. I think. Well, one thing I think what we have is if we look over here, right, input equals input.drop first, character equals input.first. I think we can switch that. And this is all working on the input. And we can make this thing do its thing. I don't know, doing the drop first sounds funny, but I think what we're going to say is get character. We want to get the next character or next character from this thing. Okay, so let's move this over to the parser, to my input. Okay, so next character is input.drop first. Character is input.first. Well, I guess this is going to return a character. Input.first. Optional type character must be unwrapped to evaluate type character. Okay. No one's calling it yet. Let's make this thing call it. Okay. So this is kind of a delegating method over to there, and then we can get rid of this somehow. Let's see. Run the tests. Are you going to work? I'm not quite sure about that first prime the pump thing. Are you frozen? Okay, it's my input of input. Self.input.first gives us character. So who's blowing up? All right, let's undo. Run the tests again. Input.drop first. Let's see who calls drop first. That's it. See, I don't really want to do this way with this my input, because we're copying this array every time you return itself. So that's not acceptable to me. You know, I don't know. Elm programs aren't going to be that huge, but like, why would I want 100,000 characters 100,000 times? You know, that's a little excessive. Okay, what's going on? So next character, I want. And call input.drop first. Input equals input.drop first. Let's take a smaller step. Let's just say this. Input is our my input, right? Let's make sure that. Yep. Okay. And now drop first. I'm not going to return anything because that's the only call. And nobody's looking. Whoops. Okay. Drop first. Okay, run this. Oh. This probably should have been drop first. Okay, let's try that. Yeah. Okay. That's progress. Lexer test parser. Okay, so next character. Now, who's calling this? Lexer init and next character. Okay. And then who's calling this? Caller is right here. Okay. I want to flip these around, and that's okay. So I want you to call next character and get the character and then drop it. Okay. I don't know what's going to happen when I flip that around, but drop first. So I'm going to say result equals first. Drop first, return result. And I'm going to change this init instead of first up here. It's going to be self.input.nextch. Is that all right? Cannot find result in scope. Okay, sigh of relief. We can get this thing in shape now. Okay, so we've seed that first character. We prime the pump. And every other time you call nextch, it's gonna update that character. Okay. And now nobody's calling first. Sorry, who's calling first? Lexer init. Rebuild. Or maybe I have to clean. It got confused. Okay, callers. Lexer init. Lexer keep. Okay. Slight bug in IDE. My input.nextch. Okay. I think this is the only real one. Let's do some inlining. Okay, if the current is greater than equal to input.count, we're going to return that character. Yes. We don't have to worry about incrementing. Otherwise, we're going to let result equal this. We know it's safe. Okay. Drop first is just current plus equal 1. Okay. Now, if you call next character, we check the count. Otherwise, we'd get the result, bump it up, and return it. I think I need those blanks to be quite content. All right. Do your work. First thing. Is anybody calling first and drop first anymore? All right. set the input, set the count. Next character grabs the next one. I'm happy. Okay. All right. Now, is this, let's see, how are we doing here? I would like to inline this. Yeah, that's nice. Okay. Everywhere that says next CH, we're going to put this. Oh, stop. Whatever I did. Bump something. Okay. I don't think it hurts the look of these things. Is that so bad? I almost think it makes it better because it's more clear to me that it's really just going out there and changing the character while it does that. So I'm going to change these. And I'm kind of looking them over as I do it, so I'm not doing a global replace. Yes, I think this is making good sense. Okay, run that. Okay. I don't think anybody's calling this. All right. So make my input use array of characters instead of string and evolve its interface. Okay. Excuse me. Now, I think we're... Well, we got 10 minutes left. I don't think we're going to write nestable in 10 minutes. I don't know. Maybe. Well, the input is not dash. We need that peak, unfortunately, I think. So we got alternatives. You can be not a dash. Okay, we're gonna have to break that out to be not a dash and not a brace. But if you're a brace, what do we want to happen? Well, if you're a brace, okay, let's revive our test. Okay, if you're a brace, okay, if the character equals brace, then something's going to happen. Well, if I want to say, this is where I want to say input.peak, right? If input.peak equals a dash, then I got to be off to the races and do a nestable comment. If it's a dash, then it's an open comment. Otherwise, I just want to consume this thing. Character equals input.nextch. Okay. And yeah, we don't care about it. Okay, so if the character is a brace and the look ahead says it's a dash, then that's exactly the conditions we want to come into nestable comment with. So we call nestable comment. It eats everything up to that last dash, leaves the character ready to go, and then we fall in. If it's a dash, we eat them. Well, we're not quite there. While the character's a dash, well, okay, let's. I think there's an error here. I think. Okay. We'll see if our test case catches this. All right, but input.peak, right? I want that to exist. Okay, and input.peak is a function returning a character, and basically we want to look at current plus 1. Okay, and if current plus 1 is too big for our input, we're going to return my input.uf. Okay. Otherwise, current plus 1 is not bigger than that. So current plus 1 exists. We can return input of current plus 1. Okay. And we'll run. It's a little bit of a sideways way to drive this peak function in. Okay, so let's see our test. Yeah, I think our test is sort of the best case. We do this stuff, we get the non-stuff, we find a brace with a dash, we go in and consume that up to here. Leaving it at the dash, we come back and say dashes. But the error case I'm worried about, nestable comment with, or nested, maybe better. Nested comment with empty comment with empty nested comment returns spaces with non-dash following returns spaces. Okay, and so non-dash following, like an X. I think that's going to get in trouble. No. Let's make sure why. Okay, so you come in here, dash brace, bunch of stuff. You hit a dash and a brace, so we call nestable. That consumes to the end of the dash brace. We come back with an X. While character is a dash, input is next. Okay, and while the character is not a brace, yeah, I can devise something tricky. Okay, let's put an extra brace in. I think that will fail. No. Come on, I got to be able to fool this thing. Okay, so it comes out. It's got an X. I guess it's not a brace. It doesn't match the dashes. Okay, I guess we're okay. It doesn't match the dashes. It's an X. It's not a brace because we're still stuck at the X, and so we go back around the loop. And yeah, so we're back around the loop, and in which case we don't worry about right braces unless we see a definite left dash in front of it. If we didn't see a dash, well, we'd still be stuck there at the non-dash and back around again. Okay. The only error I still see, that's an odd one. We mentioned earlier about. Okay, let's delete this. We mentioned about end of file showing up in the middle of one of these things. So that's where we're going to pick up tomorrow, next Tuesday. Okay, so let's see. This should run. All right, and we'll add an X test nestable comment. Returns error, I guess. And this is unterminated nestable comment returns error. Okay. So we will commit this. Nestable comments, but can't handle EOF in the middle. Okay, so we're a bit closer than I expected. All right, so ignore nestable comments. That's the story we've been working on here. And then we'll say works if no end of file occurs inside. Okay. And what's the other thing I wanted to do? I just want to do some cleanup. We did this one. What I want to do is I do want to handle EOF inside. That's kind of our first priority. But then I want to deal with that number, move number to class wide. I think we'll call it token string. Okay. And we did do this. I guess that's another refactoring. Okay, cool. All right, so well, we got a few things done. We basically got caught up to where we were from the parser combinator stuff. We're pushing beyond that now. We've got spaces, new line, end of line comments. They handle end of file. We've refactored and modified. I mean, it's almost so far now it's modifying, but we switched from my input to work with character, and we use the peek functionality in there to let us ignore nestable comments. The only thing is, if an end of file occurs in the middle, we want to get some sort of error or something um, coming back first. So we'll pick up there Tuesday, 1 to 3 p.m. Eastern, and hope you can join me then or in the future. And thanks for being here today. Bye bye.